Welcome to Preeminent Test Prep. Today is day 41 in our 90-day SAT Prep series. Today we'll be doing some stuff in the math section and then also the reading section. So for the math section today, yesterday you took SAT Practice Test 5's Math No Calculator section. Today I'll be inserting a video where I give answer explanations. I recorded this video a few months ago. This goes over the answer explanations for SAT Practice Test 5, so you'll be able to grade it, see what you got, see my thought process and compare it to yours, and then just kind of measure your growth from when you took SAT Practice Test 5 to taking this Math No Calculator section a second time. If you didn't score 100% on this Practice Test 5 Math No Calculator section, then that's an indication to you that you need to make sure you're taking more time to analyze your practice tests, especially if you're shooting for a score above 1500 or above 1400. You need to make sure that you're really getting the most out of those practice tests and never missing the same question twice. So if you missed a question on this, that really shouldn't happen because you already took SAT Practice Test 5, but if it does, that's okay. Just make sure you analyze why you got it wrong so you don't make the mistake in the future, and then also make sure you take more time then in the future on practice tests, really analyzing them and breaking them down and trying to learn from them. Okay, so with that, I'm going to go ahead and insert and embed that video that I talk about the answer explanation, so that'll start playing for you in the next 15 seconds, and then after that, I will switch over to the SAT reading section, give you my tips, tricks, and strategies for that. So that lesson for today will also be included in today's video. So with that, let's go ahead and switch over. Question 1. Which of the following is an equation of line L and the xy plane above? Well, we have line L on our graph, and we see it intersects our y-axis at 1. So we know our y-intercept will be 1, so we can go ahead and write our plus 1 in our equation. Now we have to solve for our slope. Well, we see that if we go over 1, so if we run 1, we also go up 1. So our rise over our run is 1 over 1, which means our equation will be y equals x plus 1, which is choice D. Question 2. The circle above with center O has a circumference of 36. What is the length of minor arc AC? Well, we see minor arc AC is here, and we know we have a 90-degree angle. So we know our 90-degree angle divided by our total 360-degree angle of our whole circle is 1/4. So if our angle is 1/4 of our total angle of our circle, we know our circumference of 36 times 1/4 will give us our arc length AC, which will be 36 over 4. 36 divided by 4 is 9, so we know our answer is A. Question 3. What are the solutions of the quadratic equation 4x squared minus 8x minus 12? When you see an equation like this, what you want to look for is what can be factored out. So if I see I have a 4, a negative 8, and a negative 12, I know that 4 goes into 4, negative 8, and negative 12, so I can take 4 out and write the equation as 4 times x squared minus 2x minus 3 equals 0. So now I can take my equation x squared minus 2x minus 3, and I can simplify it more to find the solutions. So I see that I have negative 3, so I'm looking for factors of negative 3 that add to negative 2. Well, factors of negative 3 that add to negative 2 are going to be negative 3 and then positive 1, because negative 3 times 1 gets us negative 3, and negative 3 plus 1 gets us negative 2. So now I know that I'll have x minus 3 times x plus 1, and then from there I just solve for x. So I can set my x minus 3 equals 0, add 3 to each side, and get that x equals 3. Or when I see x minus 3, I can just go ahead and know that it's just going to make x equal to 3. So if you can memorize that, that'll save you time. And then if I see x plus 1, then I know that x will have to equal negative 1. So my answers will be x equals 3 and x equals negative 1. And we go back up, we see which answer choice matches that. We have x equals 3 on B and on D, so we can go ahead and get rid of A and C. And then we have x equals negative 1 on B, so our answer will be B. Question 4. Which of the following is an example of a function whose graph in the xy plane has no x-intercepts? So we're looking for an equation that doesn't cross our x-axis. Alright, choice A, a linear function whose rate of change is not 0. Well, that doesn't work, because if we look, if we have a linear function whose rate of change isn't 0, so we'll call it 1, we will cross our x-intercept. So we can go ahead and get rid of A. If we look at B, a quadratic function with real zeros, well, real zeros means that it does cross our x-axis. So we can go ahead and get rid of B. If we look at C, a quadratic function with no real zeros, well, a quadratic function with no real zeros means that it doesn't cross our x-axis, which means we have no x-intercepts. So C will be our answer. Question 5. In the equation above, k is a constant. If x equals 9, what is the value of k? Alright, so we're going to have k plus 2 minus x, and we know x is 9, so we can go ahead and write minus 9 equals 0. So we're going to add 9 to each side, so that way we can square what we have under our square root. 0 plus 9 gives us 9. We have 9 equals the square root of k plus 2. We go ahead and we square each side to get rid of our square root. 9 squared is 81. So we're left with k plus 2 equals 81. We subtract 2 from each side to isolate k. 81 minus 2 gives us 79. And we have k equals 79, which is D. Question 6. Which of the following is equivalent to the sum of the expression a squared minus 1 and a plus 1? Well, all we're going to do here is we're going to add our a squared, and then we have plus our a right here, and then we have our minus 1 right here, and then plus 1. Well, minus 1 plus 1 equals 0, so they'll just cancel each other out, and we're left with a squared plus a, which is A. The answer choice, A. Question 7. Jackie has 2 summer jobs. She works as a tutor, which pays $12 per hour, and she works as a lifeguard, which pays $9.50 per hour. She can work no more than 20 hours per week. Okay, so we know our x plus y has to be less than or equal to 20, because she can work no more than 20 hours per week. Now it says, but she wants to earn at least $220 per week. So we know that she wants to earn greater than $220 per week. Which of the following systems of inequalities represents this situation in terms of x and y, where x is the number of hours she tutors and y is the number of hours she works as a lifeguard? Alright, well, if x is the number of hours she tutors, she gets paid $12 per hour doing that. So we will have 12x plus y, the number of hours she works as a lifeguard, times how much she makes as a lifeguard per hour, which it says is $9.50, so plus 9.5y. Now we just have to find which set of equations matches ours, right? So we have x plus y is less than 20, less than or equal to 20. Well, A says that x plus y is greater than or equal to 20, which is wrong. B says that x plus y is less than or equal to 20, which works. And C says x plus y is less than or equal to 20, which works. D says that x plus y is greater than or equal to 20, so D is out. Now we look at which first equation matches ours, right? So let's look at B. Well, B says 12x plus 9.5y must be less than 220. But we see in our equation, we have that it must be greater than 220. So we can go ahead and get rid of B, and we'll know that C is our answer. Question 8. In air, the speed of sound s in meters per second is a linear function of air temperature T in degrees Celsius, and is given by s of T equals 0.6 T plus 331.4. Which of the following statements is the best interpretation of the number 331.4 in this context? Well, if we think about it, our 331.4 is going to be our speed of sound in meters per second when T equals 0, right? So when the temp is 0 degrees Celsius is when our speed of sound will equal 331.4. So now let's go ahead and read through our answers. Answer choice A, the speed of sound in meters per second at 0 degrees Celsius. Yes, right? Because at 0 degrees Celsius, we would have 0.6 times 0, which will be 0, and we'll be left with 331.4 equals our speed of sound. So the answer is A. Question 9. If xy is a solution of the system of equations above, and x is greater than 0, which just means x is positive, what is the value of x times y, right? So we want to make sure we pay attention to our end question here. We're not asked for x or y or their coordinates. We're asked for x times y. So we'll first find the coordinates, then we have to remember to multiply them. Alright, so we're given that y equals x squared, so we can go ahead and plug that in to our equation for y. So we're going to have 2x squared plus 6 equals 2 times x plus 3. Well, 2 times x gives us 2x, and then 2 times plus 3 gives us plus 6. Now what we're going to go ahead and do is we're going to get all our x's on one side of our equation. So we're going to go ahead and subtract 6 from each side. And the 6's will cancel on each side. So now we're going to have to subtract 2x from each side, so we can get all of our x's on one side. So we have 2x squared minus 2x equals 0. Well, now I'm looking here, and I see I can factor out 2x, right? So I'll be left with, because we have negative 2x and 2x squared, which each have 2x, so I can have 2x times x, right? Or 2x times x minus 1. Alright, now all I got to do is set that equal to 0, right? So now I have x minus 1 equals 0, and we know that x minus 1 equals 0. We add 1 to each side, and we get that x equals 1. Okay, well now if we know that x equals 1, we can go ahead and we can plug 1 into our equation up top. So we have y equals x squared. We know our x is 1. 1 squared is 1, so we know y equals 1. We know x equals 1. We're asked for x times y. 1 times 1 equals 1. So our answer is A. Question 10. If a squared plus b squared equals z and a times b equals y, which of the following is equivalent to 4z plus 8y? Well, we're given our z in this equation, and we're given what our y equals in this equation. So we're going to go ahead and plug those equations in so we can find which equation of our answer choices is equivalent. So we have 4 times z, and we're told that z is a squared plus b squared. And then we have that plus 8 times y, and we're told that y is ab, so we have plus 8b, 8 plus 8ab. Now we multiply our 4 by our a squared, and we multiply our 4 by our b squared. We're left with 4a squared plus 4b squared plus 8ab. We can go ahead and rewrite that as 4a squared plus 8ab plus 4b squared. And what we see from doing that is we see that we have a pattern here, right? We have an a plus b squared pattern, right? If we write that out, a plus b squared is going to give us a squared plus 2ab plus b squared, right? So when we see our equation right here, now we're looking for the pattern it fits in, right? So 4a squared, well, if we have 4 as our coefficient next to our a squared, and we know that our 4 is getting squared, well, then we know we need to do the square root of 4 to find our a, right? We know square root of 4 is 2, right? And if we were to square root our a squared, because we know that that gets squared according to this equation, right? We would get a, right? So we'd have 2a. Now, if we go to our last term, we see that we have 4, right? So we're going to have square root of 4, so plus 2. And if we were to square root b as well, we'd have plus 2b. And if we look at our middle term, we have plus 8ab. Well, what's our a value? Our a value is 2. What's our b value? Our b value is also 2. And then 2 times 2 times our 2 here gets us 8. And we have our 2a and 2b, right? So those are ab. So 2a times 2b is going to get us 4b. 4b times our 2 in our equation over here gets us our 8ab. So we can go ahead and see that this equation here will be our solution. So now we just find which equation matches it, and the only equation that matches our equation is B. So B will be our correct answer. Question 11. The volume of right circular cylinder A is 22 cubic centimeters. What is the volume in cubic centimeters of a right circular cylinder with twice the radius and half the height of cylinder A? Well, we know our 22 cubic centimeter volume of right circular cylinder A is equal to pi times r squared times our height, because that is the equation for volume of a right circular cylinder. So we're going to use the factor of change method to find out how many times bigger or smaller our new right circular cylinder is than our old one, right? So what we're going to do is for every variable that stays the same, we put in a 1. So our pi will stay the same, so we put in a 1. Our radius squared, well, our radius is now twice our former radius, so it's going to be 2 squared. And then we're going to have that times our height, which it says is half the height of cylinder A. So we're going to have that times h, which stays the same, so we call h1 over our 2, because it's half the height. So now we go ahead and we solve for this, and this will tell us how many times bigger or how many times smaller the new right circular cylinder is in volume. So 1 times 2 squared, we know 2 squared is 4, and then 4 times 1/2 leaves us with 4/2. So we're going to have 2 times bigger, right? So we're going to be 2 times bigger than our 22 centimeter cubed volume. So we're going to go 2 times 22 cubic centimeters, which will give us 44 cubic centimeters. So our answer will be C. Question 12. Which of the following is equivalent to 9 to the power of 3/4? Well, we know 9 equals 3 squared. So now we're going to have 3 squared times 3/4 in our exponent, right? So to solve this, what you're going to do is you're going to do 3, and then for your exponents, you're going to have 2/1 times 3/4, and then you just solve that like you would normally with fractions, right? So you're going to be left with 3 to the power of 2 times 3, which is 6, over 4 times 1, which is 4, so 3 to the power of 6 divided by 4, which can be simplified down to 3 to the power of 3/2. Now when you have a base to the power of a fraction, your denominator is going to be what root you are, right? So in this case, our denominator is 2, so we're going to have the square root of 3 to the power of 3, because your numerator is what goes in our root box, right? So you're going to have the second root of 3 squared. Well, we know that with the second root of 3 to the power of 3. Well, we know that 3 to the power of 3 can be rewritten as 3 times 3 times 3. We take out 2 because that's what our root is, right? Our root's 2. So any groups of 2 we can take out. So we can go ahead and take out a 3, and we'll have 3 root 3 because we still have this 3 left. So we'll be left with 3 root 3, and that will be our answer, which is D. Question 13. At a restaurant, n cups of tea are made by adding tea bags to hot water. If t equals n plus 2, how many additional tea bags are needed to make each additional cup of coffee? Well, if we need one more cup of coffee, which is represented by n, we will have to increase t by 1, right? Because 2, we can think about this as our y-intercept, right? If our y-intercept's 2, we just have y equals x, right? So one more t, if we wanted one more bag of, or one more cup of tea, we need one more bag, right? Because it's just y equals x is how we can view it. So we know our answer will be B1. Question 14. The function f is defined by the equation above. Which of the following is the graph of y equals negative f of x in the xy plane? Well, we know y equals negative f of x. We're told f of x is equal to 2 to the power of x plus 1. So we'll have negative 2 to the power of x plus 1. We distribute this negative 1 here, and we get negative 1 times 2 to the power of x. That will be negative 2 to the power of x, and negative 1 times 1 just gets us negative 1. So we have y equals negative 2 to the power of x minus 1. Now we just find which equation, or which graph shows our equation, right? Well, if we know we have negative 2 to the power of x, any number to the power of x, so say 2 to the power of x, if x is negative, so on the left side of our y-axis, if x is negative, that just means 1 over 2 to whatever the absolute value of x is, right? So we know that this right here, this 2 to the x, can't ever change signs, right? So 2 to the x, it will always be positive, right? It can't go negative, but we know that it is, in this case, multiplied by negative 1. So it will always be negative, right? It will never switch. So we'll always have this value, our negative 2x, being negative, and then we always have that minus 1, right, as shown above right here. So we know our answer will always be negative. So any answer that goes positive can go ahead and be eliminated. And now we are just left with C. Question 15. Alan drives an average of 100 miles each week. His car can travel an average of 25 miles per gallon of gasoline. Alan would like to reduce his weekly expenditure on gasoline by $5. Assuming gasoline costs $4 per gallon, which equation can Alan use to determine how many fewer miles he should drive each week? Well, he wants to save $5. In order to save $5, how much fewer miles does he have to drive? Well, his car gets 25 miles to the gallon. So if he drives, we'll say M is 25, right? If he drives 25 miles less, then he's going to save $4, right? Which means that this will get multiplied by $4, because 25 over 25 will be 1. 1 times 4, he's going to save $4 if he decreases his amount of miles driven by 25, right? So we're left with 4m over 25 equals 5. So 5 equals 4m over 25. We find which equation matches ours. We see that equation D matches ours. So our answer is D. Question 16. Maria plans to rent a boat. The boat rental costs $60 per hour, and she will also have to pay for a water safety course that costs $10. Alright, so that's our equation right there. $60 per hour H plus $10 for the boat safety course. Maria wants to spend no more than $280. Alright, so we can get rid of our Y because we know that she wants to spend no more than $280. So $280 must be greater than or equal to $60H plus 10. If the boat rental is available only for a whole number of hours, what is the maximum number of hours for which Maria can rent the boat? So we just go ahead, we subtract 10 from each side so we can isolate H. 280 minus 10 gives us 270. Now we divide each side by 60 so we get H alone. And now we have H must be less than or equal to 270 over 60. 270 over 60 we can just think of as how many times can 6 go into 27, and since we actually know that it has to be a whole number, we really don't even have to do long division. We can really just say what's the most amount of times 6 can go into 27. We know that that's 4 because 6 times 4 gives us 24, but if we did 6 times 5 that would be 30. So we know that the most times 60 can go into 270 will also be 4. So our answer will be 4. What value of P is the solution of the equation above? Alright, here all that we're going to do is we're just going to have to multiply our 2 by our P and 1, multiply our 8 by our P minus 1, get all our P's on one side, and solve for our answer, right? So 2 times P gives us P, plus 1 times 2, which is plus 2, plus 8 times P, so plus 8P, and then plus 8 times negative 1, which means plus negative 8, so just minus 8, and that equals 5P. Well, we can go ahead and do our 2P plus our 5P. That's going to give us 10P. We'll do our 2 minus our 8 minus 6, and that will equal 5P. Go ahead and we will subtract 5P from this side so we keep P positive. Subtract 5P from our other side. 10P minus 5P gets us 5P. We add 6 to each side, and we get 5P equals 6. We divide each side by 5 to isolate P, and we get P equals 6 over fifths. We make sure that that's what the question is asking because we always want to answer what the question is asking. It's asking for the value of P. So our answer is going to be 6 over 5 or 1.2. Question 18. The system of equations above has solution xy. What is the value of x? Alright, well to solve for x we can go ahead and substitute in our equation here, our y equals 2x for our y right here. So we're going to have 1/2 2x plus 2x because y equals 2x equals 21 over 2. Now we can go ahead and see 2x plus 2x, that's 4x. 4x times 1/2 is the same as 4x over 2. And we know that 4x over 2 is going to give us 2x. So we'll have 2x equals 21 over 2. We'll divide each side by 2 to isolate x, right? And we know dividing 21 over 2 by 2, we just multiply by 2 in our denominator to get 21 over 4 equals x. So our answer will be 21 over 4. Question 19. The expression above is equivalent to a divided by x plus 2 squared, where a is a positive constant and x cannot equal negative 2. What is the value of a? Okay, well I see I have x plus 2 squared in my denominator here, and I know that since I'm subtracting fractions, anytime I'm adding or subtracting fractions, I need a common denominator. So I'm going to go ahead and multiply this side by x plus 2 as well. Now all I got to do, since I have a common denominator, to subtract these, right? So I'll have 2x plus 6 minus my 2 times my x, and then my 2 times my plus 2. So minus 2 times my x, which is minus 2x, and then minus 2 times 2, which is 4, so minus 4. So now I'll be left with my 2x minus 2x canceling out and ending with 0x, and then my 6 minus 4 giving me 2. So I'm left with 2 over x plus 2 squared. I'm asked for my a value only, so my answer will be 2. Question 20. Intersecting lines at R, S, and T are shown below. What is the value of x? Alright, well I see I've got 106 on line S here. I know that this equals 180, so my angle here is going to equal 180 minus 106, which will give me 74. Now I know all my angles in this triangle here add to 180, so I'm going to do 180 minus 23 minus 74. I know minus 23 and minus 74 become minus 97, so I've got 180 minus 97, which equals 103. So that means my angle here will be 103. I know this right here is going to be, I'm sorry, I don't want to write that so it looks like that's the answer for x. So I know my line right here, this angle will be a total of 180 because it's on a line. So now I just do my 180 minus my 103 degrees equals x. Doing that, 180 minus 103, I get 97 equals x. So I know my answer here will be 97 because I'm asked for the value of x. Alright, so for the reading section today, we're going to be doing one passage. This is going to be from SAT Practice Test 5. This is the last passage in SAT Practice Test 5. It's questions 42 through 52. So what I'm going to be doing here is this is a science section. So I'll be breaking down how I approach the science section. It's a one passage science section, right? So no comparing between two different things. As I go through it, I'm really going to be trying to break down what I look for on the SAT reading section, especially in particular the science passages, because there are 2 science passages per SAT reading section. So I'll really be breaking down kind of the differences as far as things I look for here. One of those I talked about a couple days ago was being those problems and those solutions. So if I see a problem stated in it, I'm going to highlight that. If I see a solution, I'm going to highlight that. So kind of trying to give you an idea of how you can approach these science passages in order to maximize your efficiency, become more efficient, improve your accuracy as far as what you're answering. And then as we get into pretty much, I'd say probably late next week or pretty much 10 days from now, anywhere from 5 to 10 days from now, we're going to start working more on pacing with the reading section. So we've worked a lot on accuracy up to this point. Really kind of going forward after probably about next week or maybe in 5 days from now, 10 days from now is when we're really going to start working on pacing, okay? So at that point, we might be doing 2 passages per day. So really trying to work on that pacing, but for now, we're really focused on accuracy still. So this will be probably one of the last days where we really focus on accuracy, and then after that, we're really going to start focusing more on pacing, because at that point, or at this point, you really should be getting more comfortable with how to be accurate in your answer choices. All right, so with that introduction for today, let's go ahead and get into our passage. So this passage is adopted from Joshua 4. It's titled Moonwalking with Einstein, the Art and Science of Remembering Everything. Copyright 2011 by Joshua 4. In 2000, a neuroscientist at University College London named Eleanor Maguire wanted to find out what effect, if any, all that driving around the labyrinth streets of London might have on cabbies' brains. When she brought 16 taxi drivers into her lab and examined their brains in an MRI scanner, she found one surprising and important difference. The right posterior hippocampus, a part of the brain known to be involved in spatial navigation, was 7% larger than normal in the cabbies, a small but very significant difference. Maguire concluded that all that wayfinding around London had physically altered the gross structure of their brains. The more years a cabbie had been on the road, the more pronounced the effect. The brain is a mutable organ capable within limits of reorganizing itself and readapting to new kinds of sensory input, a phenomenon known as neuroplasticity. It had long been thought that the adult brain was incapable of spawning new neurons, that while learning causes synapses to rearrange themselves and new links between brain cells to form, the brain's basic anatomical structure was more or less static. Maguire's study suggested the old inherent wisdom was simply not true. After her groundbreaking study of London cabbies, Maguire decided to turn her attention to mental athletes. She teamed up with Elizabeth Valentine and John Wilding, authors of the academic monograph Superior Memory, to study 10 individuals who had finished near the top of the World Memory Championship. They wanted to find out if the memorizers' brains were like the London cabbies, structurally different from the rest of ours. or if they somehow just make better use of the memory abilities we all possess. The researchers put both the mental athletes and a group of matched control subjects into MRI scanners and asked them to memorize 3-digit numbers, black and white photographs of people's faces, and magnified images of snowflakes while their brains were being scanned. McGuire and her team thought it was possible that they might discover anatomical differences in the brains of the memory champs. Evidence that their brains somehow reorganized themselves in the process of doing all that intensive remembering. But when the researchers reviewed the imaging data, not a single significant structural difference turned up. The brains of the mental athletes appeared to be indistinguishable from those of the control subjects. What's more, on every single test of general cognitive ability, the mental athletes' sensors came back well within the normal range. The memory champs weren't smarter and they didn't have special brains. But there was one telling difference between the brains of mental athletes and controlling subjects. When the researchers looked at which parts of the brain were lighting up in the mental athletes during memorizing, they found that they were activating entirely different circuitry. According to the functional MRIs, the regions of the brains that were less active in the control subject seemed to be working in overdrive for the mental athletes. Surprisingly, when the mental athletes were learning new information, they were engaging several regions of the brain known to be involved in 2 specific tasks: visual memory and spatial navigation, including the same right posterior hippocampal region that the London cabbies had enlarged in all their wayfinding around. At first glance, this wouldn't seem to make any sense. Why would mental athletes be conjuring images in their minds when they were trying to learn 3-digit numbers? Why should they be navigating like London cabbies when they're supposed to be remembering the shapes of snowflakes? McGuire and her team asked the mental athletes to describe exactly what was going through their minds as they memorized. The mental athletes said they were consciously converting the information they were being asked to memorize into images and distributing those images along familiar spatial journeys. They weren't doing this automatically or because it was an inborn talent they nurtured since childhood. Rather, the unexpected patterns of neural activity that McGuire's fMRIs turned up were the result of training and practice. Alright, so let's go through why I highlighted the things I highlighted. That way you can get an idea of how I approach these science sections and what I would underline if I were taking the SAT and going through a science section. So let's go ahead and get started up here. Okay, first thing, obviously introduction. I do this every single time. Always underline author, the title, and the copyright year as well as the author, right? So if I have a written year, the date it was written or published, I do that as well. So next thing I have is she found one surprising important difference. Okay, anytime I see something that says one, like there's one of something, best of all, only one, worst of all, anything that isolates one certain thing is something I'm going to pay attention to, right? So she found one surprising and important difference. The right posterior hippocampus, part of the brain known to be involved in spatial navigation, was 7% larger in the cabbies, a significant difference, right? Okay, so that is really something that is surprising, right? Anything surprising, I want to make sure I highlight that. But really, most importantly, anything that says one or isolates one thing from another, I always want to make sure that I'm highlighting or underlining that. Okay, so I talked about that before. That applies to the science section as well. Okay, we see that they physically altered the structure of their brains. That's a claim. Okay, it's a claim and it's backed by evidence, so it's really a fact, claim/fact. With the science section, you can have facts, like claims can be facts. They can be interchangeable at times. In this case, it's a claim that is a fact. All right, and then we also read that the more years they've been on the road, the more pronounced the effect, also claim/fact. So I'm going to highlight that. Okay, the brain is a mutable organ, which within limits is capable of reorganizing itself and readapting to kinds of sensory input, a phenomenon known as neuroplasticity. Okay, once again, this is a claim. Now, this is also a little bit of explanation, so if you didn't want to highlight this, that would be okay as well because it is a bit of explanation. So if you're trying to highlight less things, this would be something you could cut. All right, next we have McGuire's study suggested the old inherent wisdom was simply not true. This right here is a very, very strong claim and very, very central to our passage, okay? We're discussing how the old claim that the brain's structure couldn't change is not true. We're saying that the brain's structure can change. That's a major claim in the passage, so we definitely want to highlight that one. That one is not something we could cut. Okay, structurally different from the rest of ours, or if they show them making better use of the memory abilities we all possess. So this isn't talking about those London cabbies. This is really our driving question behind our experiment. So anytime I have a driving question behind my experiment or a hypothesis, I want to highlight that. Okay, so this is my driving question behind the experiment. Are their brains different or are they just using their memories differently? So that's my driving question. Anytime I have a driving question on a science section, I want to highlight that. Then I have, but when the researchers reviewed the imaging data, not a single significant structural difference turned up. So this isn't talking about the mental athletes here rather than the cabbies. Okay, and this is really summarizing our findings. Okay, if I have a summarizing of my results, I'm going to want to highlight that. Okay, I'm not going to highlight a whole paragraph, right? If there's a whole paragraph of summarizing my results, I don't want to highlight that. But if I can get it down to one sentence like this is right here, that's something I want to highlight. Okay, next, but there was one telling difference between the brains of mental athletes and control subjects. Okay, once again, this is kind of summarizing our findings in a short thing. Okay, also you see this right here. Okay, that saying that there's one thing, one difference, I always want to pay attention to those. Anytime I see there's one, or the best of all, or least of all, or anything that's indicating one thing, I always want to pay attention to that. So that's really part of why I'm highlighting this here. So when the researchers looked at which parts were lighting up, they found that the control versus the mental athletes were using entirely different circuitry or entirely different parts of the brain. Okay, so this is very, very, once again, surprising findings, indicating that it's one thing that's very important, so I'm going to highlight that. Okay, we have visual memory and spatial navigation, including the same hippocampal region the London cabbies had enlarged with all their day finding. Okay, so this is showing me, and I just erased my highlights, so I'll just quickly redo that. Okay, this is something that's comparing my two experiments. If I ever have a science passage and we have two experiments contained in it, one thing I want to do is I want to pay attention to any connections between those two. So any connections between two experiments within one passage, I want to make sure that I'm making those connections. So in this case, we see a connection between the London cabbies here and those mental athletes. I want to make sure I pay attention to that connection. So connections between experiments, I always highlight those. Connections between experiments. And that's really, really bad handwriting there. So just understand that says connections between experiments. Okay, down here we've got McGuire's fMRIs turned up when they were the result of training and practice. Okay, this right here, this is important because it's really summarizing our passage, or not necessarily our full passage, but it's summarizing our findings, right? We found that McGuire's fMRIs showed that those changes and that neural activity that we see in those professional memorizers, that's the result of training and practice, not the result of them having a different brain structure. Okay, so that's really an important finding that's kind of relating back to our driving question. Anytime I answer my driving question, I always want to highlight that. All right, now we've got our questions. So let's quick run through these. This one, it's probably going to take I have no clue how long this is going to take, to be honest, for these questions here. We'll just see. It shouldn't take more than 15 minutes, though. We'll try to keep it under 15. But I do want to take time to give you all the advice that I can here. So we have, according to the passage, McGuire's findings regarding taxi drivers are significant because they what? Well, the whole point of her seeing these taxi drivers, and I think we highlighted this as well, it's significant but because it's challenging that old inherited wisdom, right? We used to think that the brain was not capable of changing its anatomical structure at an adult age, okay? But we see that according to this study with these cab drivers, that's not true. So it's changing that long thought or long held belief, okay? So let's go ahead and take a look at our options for 42. We see option A says demonstrate the validity of a new method. No, we're not demonstrating the validity of a new method. B, providing evidence for a popular viewpoint. There is no popular viewpoint we're providing evidence for. C, calling into question an earlier consensus. Yes, absolutely. Right, I just pointed out in my evidence there, and we have an evidence question up here, so that's probably what our evidence will be. I pointed out how it was previously thought the brain's anatomical structure could not change, but now it's showing it can. Okay, D, challenging authenticity of previous data. We don't discuss previous data, so that's why that's wrong. As far as what question type this is, this one right here, I would say that this one's a little bit tough. So as far as a question type, there are some questions that don't necessarily fall into one box. I'd say this is closest to a little detail question, but also some things are between little detail questions and big picture. I'd say this is one that's kind of between them, but if I had to pick a box, I would say it's in the box of little detail question. But all right, now our evidence there, I'm going to go check and see if we have those lines I just saw. So that was 25 to 26, right? I just talked about those. We'll see if we have something along those lines. I see I have 20 to 26, and 20 to 26 will be my answer, right? We just really want to include the fact that it's changing that anatomical structure, right? We want to include that it says, or where was it? Up here. Okay, so 20 to 26, right? That long thought belief about the adult brain being incapable of spawning new neurons, right? We're including that. Really including that full sentence before it and the sentence after. So 20 to 26 is great evidence there. Obviously 43 is then an evidence question. Answer there is going to be D. All right, now we've got question 45. So 45, as used in line 24, basic most nearly means what? Well, let's go take a look at line 24, come up with our own answer choice for what basic means. All right, so I'm going to erase some of this so you can see it more clearly. I'm going to switch to a blue pen so you can see what I'm doing. We're looking for what the word basic means right here. Okay, I'm going to zoom in a little bit as well, if I can. Okay, it's not letting me zoom in. All right, there we go. Okay, so while learning causes synapses to rearrange themselves and new links between brain cells to form, the brain's basic anatomical structure was more or less static. Well, we're talking about this in the context of the adult brain being incapable of spawning new neurons. Okay, so what we're really talking about here is the brain's fundamental structure, or the structure that it takes on from birth, right? That fundamental structure, and you're not going to be able to read that because my handwriting's too bad and this is too big of a pen to do it in. So I can switch over to my other. But we know that that's going to be fundamental, right? That basic anatomical structure is referring to the structure of that brain from birth, okay? So that's its fundamental structure. Its structure before it gets these alterations from driving around in a cab. So let's see if we have fundamental in our answer choices. We see that we do. We wouldn't say it's the brain's necessary anatomical structure because it isn't necessary because it's changeable. As far as it being a simple structure, no, because the brain is very complex. And as far as initial structure, not that as well, because when we're talking about fundamental, while we are kind of talking about it being from birth, we're also talking about it being just the normal structure, okay? So initial covers the part where it's kind of that brain structure that you kind of have from birth before your brain changes, but it doesn't capture that part where it talks about how that brain, its fundamental structure referring to how most people have that structure. Initial would be incorrect because it doesn't include the part of it being that structure that most people have, right? Fundamental, it's going to take that both from birth part and it's also going to have the other part that is it being the structure most people have. So that's why D is correct for 44. And obviously it's a words in context question because it's most nearly means, right? Anytime we see most nearly means, we know it's words in context. All right, question 45. So 45, let's go ahead and take a look at it. Which question was McGuire's study of mental athletes primarily intended to answer? Well, that question, right, that study was intended to answer was whether or not these people who have these fantastic memories, it's the result of having pretty much a born brain that is different from other people, or whether they're using that brain differently. Okay, so that's really what that one's digging in at. So let's look at our options, find something that says something along those lines. So A says, does the act of memorization make use of different brain structures than the act of navigation? No. Okay, that's conflating those two studies. These are two different studies. We'd be conflating the one with the cabbie drivers if we're including that. So that's why that's wrong. B, do mental athletes inherit their unusual brain structures, or do the structures develop as a result of specific activities? Okay, once again, this is wrong. So what makes this wrong? Well, this first part is correct, but the second part is incorrect. Saying do the structures develop as a result of specific activities? That's not what we're testing. We're testing whether they have different brain structures or if they're using different parts of their brain. Okay, we're not studying whether or not they develop different parts of their brain, right? Or whether those specific activities develop those parts of the brain. C, does heightened memorization ability reflect abnormal brain structure? Yes, that's correct. Or an unusual use of a normal brain structure. Okay, so this is really getting into that nature versus or I guess not nature versus nurture, forget what I was saying there. This is getting into that discussion that we talk about in our passage between, are these people with great memories, do they have abnormal brain structures, meaning they have some enlarged portion of the brain somewhere, or are they just using that brain differently, right? It's a normal structure, they just use it in a different way. So that's really what that second study was about, and that's what our correct answer would be right there. So C would be our correct answer for 45. This one right here, this is basically, I would include this as a purpose question. It's less about the purpose of including some lines, but it is about the purpose of a study, right? So I would consider this still a purpose question, just not what you typically see with a history passage type of purpose question or a literature passage type of purpose question. All right, so we got C for 45. Now we can go and move on to 46. All right, so we got best evidence for that. Okay, we're going to find where our evidence is for that. So that's going to be pretty much where we talk about, let me go find it real quick. I think I might have highlighted it. Let's take a look. Okay, it's going to be pretty much right here. They wanted to find out if the memorizers' brains were like the London cabbies, which are structurally different from the rest of ours, or if they were somehow just making better use of the memory abilities we all possess. Okay, so we see I highlighted that as my driving question. That's really what they're trying to answer. And since our question before it was really diving into which question they want to answer, this would be great evidence for it. So I see that that's going to be lines 33 to 37. So that's really what I'm looking at there. So I'm going to scroll down here, find option there, and that's going to be obviously B. So B would be my correct answer for my evidence there because that's where we talk about that driving question. So I hope that that really helps you to see. Obviously, I'll just quick answer this. This is an evidence question. Okay. So I really hope that that's starting to help you see how important it is to, as you go through these science sections, making sure that you are highlighting things such as solutions, problems, driving questions, answers to the driving question, because really you oftentimes see that those are the types of things that end up needing to be recalled for providing evidence for evidence questions. Okay, as used in line 39, matched most nearly means what? Obviously words in context question because it says most nearly means. We can go ahead and run up to line 39 and see what matched most nearly means. So let's go ahead and do that. So line 39 is right here. Okay, I'm going to put it in blue so you can see it better. All right, we've got the researchers put both the mental athletes and a group of matched control subjects into MRI scanners and asked them to memorize 3-digit numbers. Okay, so one thing you really need to know to get this right is what a control subject is, okay? Control subjects are subjects that are similar to the mental athletes in this case, okay? Control subjects are meant to be very, very similar to whatever subjects we are studying, okay? So whatever our different thing is, the control subjects are going to want to be as close to them as they can. They really only want to lack that subtle difference that makes them the difference. So in this case, it's mental athletes versus control subjects. For example, the control subjects would be people who are comparable in weight, in height, in age, in education, things like that. That way, where they're controlling for those variables such as education and things like that. Geographic region as well, possibly. So right there, matched control subjects most nearly means probably comparable or comparable control subjects. Similar would also be a good answer choice. Similar control subjects, but I would say comparable would be my best answer there. So let's look if we have either of those. We do not have similar, but we see we do have comparable. Okay, so that would be our answer choice there for 47. It'll be A. As far as why B through D are wrong, let's go ahead and cover that. They can't be identical. That's physically impossible unless we had twins, but even then, there would be some subtle differences. Also, if we're doing twins, then it's not really matched control subjects, because if we're doing twins, well, I guess it would be. So either way, but the control subjects aren't identical. We know that, so we can go ahead and get rid of that. Forget what I was saying about twins. That complicates it more than it needs to be. Let's keep it simple. We know that the control subjects aren't identical because that would be impossible. C, distinguishable. No, we want the opposite of distinguishable. We want them to be very, very similar or very, very comparable. Competing, they're not competing against them. Okay, this isn't a contest. This is just seeing how the brains are functioning. All right, the main purpose of the fifth paragraph is to do what? Obviously, it's a purpose question because we're asked for the purpose of this fifth paragraph. Let's go take a look at that fifth paragraph. It said 57 to 65 was our lines. 57 to 65. All right, well, I see what I'm talking about here is I'm summarizing my findings, or I have surprising findings, I'm sorry. I have surprising findings of these entirely different circuitry that's being used, so I'm summarizing my experiment there. So summarizing my experiment, stating my surprising findings is really what I see going on there. So I'm going to look for an answer choice that says that. Let's take a look. So we've got 48. Let's go ahead and just go A through D, and we'll just take a look at each answer choice, see which one's correct. So we have option A, relating his study of mental athletes to her study of taxi drivers. No, we're not relating it to the study of taxi drivers. And even if we were, that's definitely not the main purpose. Speculating on the reason for McGuire's unexpected results. We are not speculating. C, identifying an important finding of McGuire's study on mental athletes. Yes, okay. We are summarizing our findings, and in that summary of our findings, we are identifying that important finding of the mental athletes using their brains differently, okay? So we're definitely identifying that important finding. As far as D, transitioning from a summary of his findings to a description of our methods, we don't transition to a description of our methods, so D would be incorrect. All right, so yeah, the main purpose of that paragraph is most definitely identifying the fact that mental athletes are using different parts of their brain than other people are, but their brains are not different in a structural sense. So 48 there, our answer is going to be C. Now we can go ahead and move on to question 49. 49 says, according to the passage, when compared to mental athletes, the individuals in the control group in McGuire's second study, what? All right, well, those in the control group, we know that they use their brains differently. They use different parts of the brain. It never says that they showed less brain activity overall. In fact, I believe it said that they were comparable in brain activity, just using different parts of the brain. As far as B, demonstrate a wider range of cognitive ability. No, okay? They're just exhibiting different patterns of brain activity. That's correct. Right, they're using different parts of their brain. So 49, answer there is going to be C. They're using different parts of their brain than those mental athletes are. D, displayed noticeably smaller hippocampal regions. No, okay, that's a structural difference. We know that they used their hippocampal regions less, but they were not smaller, okay? So D is incorrect. 50, the passage most strongly suggests, so since it's saying it most strongly suggests, that tells me it's an inference question, that mental athletes are successful at memorization because they what? That's going to be them training, right? We talk about that at the end. Them converting those images into, them converting that information they're asked to memorize into images, distributing those images along familiar spatial journeys. We know that this is the result of training and practice. So we're going to look for an answer choice that encompasses all of that. So let's just run A through D, figure out which one's right. That's going to be how we're going to do this one. So we got option A, exploit parts of the brain not normally used in routine memorization. Okay, that's going to be our correct answer. Now, why is that correct answer? Well, we know that they're using the parts of the brain that aren't normally used in routine memorization because they're using that region of the brain that is known for remembering things visually, right? They're using that visualization tactic to remember those things, visualization. Okay, we know that those normal control subjects were not using it anywhere near as much as these other people were. Okay, so they're definitely exploiting those other parts of the brain that aren't normally used by people in memorization. All right, let's just run through B, C, D, show why they're wrong as well. B, convert information they're trying to use into abstract symbols. We never say it's abstract. Okay, never say it's abstract. Also, symbols, better word there is going to be images. Okay, so that's why B would be wrong. C, organizing information into numerical lists. No, we don't actually organize them into numerical lists. We convert them to images, so C is absolutely factually wrong. D, exercising their brains regularly through puzzles and other mental challenges. We never say it's through puzzles. Okay, so that's why that D is wrong. Never say it's through puzzles. Okay, we've got 51 and 52 left. These are the last two questions. I'm asked for evidence at this point. So as far as evidence, I'll go back through. I'll just run through, find where we talked about the them using brains that are parts of their brain that isn't normally used. Parts of the brain that's not normally used. So that's really going to be where we talk about, let's see here. According to the functional MRIs, regions of the brain that were less active in the control subject seem to be working in overdrive for mental athletes. So that's from 62 to 65. Okay, so that's, I'm gonna put this in blue so you can see it better. I'm just gonna underline it. Okay, according to the functional MRIs, regions of the brain that were less active in the control subjects seem to be working in overdrive for the mental athletes. I'm going to scroll to my right, put a big star there so you can see where I'm at. It's right there. We see it's from 62 to 65. That's really showing that the regions of the brain that were less active in control subjects were working in overdrive for mental athletes. That's 62 through 65. That would be my evidence there. I'm going to see if I have that. I see I don't have that. Okay, so that means I got to find it somewhere else. Okay, if that ever happens to you, where you think evidence is going to come from one spot and you don't see it there in your options, that's okay. Don't panic. Just go find the evidence somewhere else. Everything's going to be okay, right? So don't panic here. Okay, if we're just talking about it right there, what I'm just going to look to do is I'm just going to look right after it because it's quite possible we just continue that discussion on in our next part. So surprisingly, when the mental athletes were learning new information, they were engaging several regions of the brain known to be involved in two specific tasks, visual memory and spatial navigation, including the same right posterior hippocampal region, the London cabbies enlarged in their daily wayfinding. At first glance, this wouldn't make any sense. Okay, so that's showing that this isn't expected in other people. Okay, because it's not generally what people would expect for people to do when they're memorizing, to be using spatial navigation. Okay, so I'm looking from pretty much the start of this, basically 66 to 74. I'm going to see if I have something like that, or 66 to 73. Let's see if we have either of those. Okay, I see I do have 66 to 72 there. So that would be my correct answer there, right? We talk about how it's a surprise, right? Which means that it's not expected for them to be using those parts of the brain, which shows that they are using parts of the brain not normally used in routine memorization. It's a surprise that they're using these parts of the brain. So that's going to be our evidence there, 66 to 72. Okay. So right there, that's a perfect example of not panicking if you find evidence, right? You go back, you find it, and you realize that they don't have those lines there. That's okay, don't panic, just look around, right? So what I do if I ever ran into that, right, I found evidence and then I realized I didn't have lines for it, what I would immediately think is I would just think, what's the closest lines to it? We saw that the lines right after it, right, were the closest to it, right here, lines 66 to 72, they were the closest to what we just found. So we just simply looked there. We saw that that did just as good of a job of providing evidence, right? So it did perfectly fine job of providing the best evidence there. So 51, answer there is going to be A. That's an evidence question. Okay. All right, 52. The questions in lines 74 to 78 primarily serve to do what? All right, well, let's go take a look at those lines, and then we'll come up with our own answer choice for that one. All right, so what did it say? 74 to 78. Let's go ahead and find that. That's going to be up here. Okay, what are these lines serving to do? I'm going to erase some of this so you can see it better. I'm going to put it in blue as well so you can see it better. Okay, so we have, why would mental athletes be conjuring images in their mind when they're trying to learn 3-digit numbers? Why would they be navigating like London cabbies when they're supposed to be remembering the shapes of snowflakes? Well, this is, for one thing, this is kind of introducing what's to come, our explanation of that. But what it's really doing is it's creating this, it's creating a sense of I'm trying to think of what the word is here. It's basically creating a sense of us wanting to know the answers to these questions, right? So it's wanting us to keep read. So that's really what it's doing, literary, right? But as far as what it's doing, as far as scientifically, really what this is doing here is it's showing how surprising these results are and how they're unexpected. So I'm going to look for something that talks about how they're unexpected results, and it's really kind of highlighting that part. Let's see if we have an answer choice that says anything along those lines. All right, so let's just run through A through D here, see which one says something along those lines. So we have option A, raising doubts about the reliability of the conclusions. No, we're not raising doubts about reliability. Nothing indicates that these conclusions are unreliable. B, emphasizing and elaborating on an initially puzzling result of his study of mental athletes. Yes. Okay, we are emphasizing the fact that we don't understand at first why they're using their minds like London cabbies when they're just memorizing sets of data or numbers or sequences of numbers. Initially, that's puzzling to us because we don't know why they're using visual parts of the brain to do that. So that's really showing us that that is initially puzzling. So B would be our correct answer there. As far as why C and D are wrong, let's cover that real quick. C says imply that McGuire's findings undermine earlier studies of the same phenomenon. Okay, we are not implying that they are undermining earlier studies, so we can get rid of C. D, introducing and explaining connection between McGuire's 2 studies and her earlier work. We are not introducing and explaining a connection there. At that point, all that we're doing is emphasizing that initial puzzlement behind why they're doing this, right? We're not sure. We're not really connecting them there. We are just showing that it's surprising. Okay, so B would be our correct answer here. This is a purpose question as well. Forgot to answer question types, I think, maybe on these last couple, but maybe I did get them. Yeah, I think I got them. I got question types on most of them, I think. All right, so that takes us through our reading section today. As always, if that was helpful, there'll be a donation link in the description when it's up and running. Any private SAT tutoring I'm doing will be linked in the description. Any private college admissions consulting I'm doing will be linked in the description. As always, thanks for watching. Make sure to like, share, and subscribe, and have a good day.